China is executing a $66 trillion roadmap to conquer the lunar surface. While Western headlines obsess over NASA's shifting deadlines and budget cuts, China's moved into hyper-production mode. They're systematically checking off every box required for permanent colonization. Not a research outpost, not a flags and footprints mission, a colony. Here's the 10-year timeline. It starts with robotic survival tests happening right now and ends with a nuclear-powered industrial base going live in 2035. The moon is about to stop being a frontier and start being territory. In 2029, China lands its first taikonauts on the lunar surface. The date isn't flexible. It marks the 80th anniversary of the People's Republic of China, a national celebration of power. Here's the engineering problem. Landing people on the moon typically requires one monstrous rocket that takes decades to perfect. China doesn't have decades, so they're using a double launch strategy. Two separate Long March 10 rockets lift off. The first carries the Mengzhou crew spacecraft, a 26-ton capsule designed to support 3 astronauts. The second carries the Lanyu lunar lander, also weighing in at 26 tons. These vehicles rendezvous and dock in lunar orbit. Then 2 astronauts transfer to the lander for touchdown while one stays in orbit. Pragmatic, safety first. The Long March 10 itself is a 90-meter-tall beast with 3 stages and 2 liquid-fueled side boosters. Each booster packs 27 metric tons of lunar orbit. China even plans to make the boosters reusable, catching them with wire tethers instead of landing legs. Instead of gambling everything on one giant engine, they split the risk. This lets them use existing technology and get into service faster than anyone expected. The first Chinese stay on the moon will be relatively short, 6 to 8 hours of exploration, sample collection, experiments. Then they return home. That 2029 landing gets the headlines, but it's the least ambitious part of their plan. China realized something. If you want to build a lunar civilization, disposable rockets are dead. The problem? They'd spent over 10 years developing the Long March 9 as a traditional expendable heavy-lift vehicle. Their solution? Scrap it. Start over. The original Long March 9 was announced in 2011, a 103-meter-tall rocket with a massive 9.5-meter diameter core stage. It was designed with 4 chemical side boosters, each powered by dual-chamber YF-130 kerosene engines, producing 480 tons of thrust. The plan was to launch 140 metric tons to low Earth orbit, 50 tons to lunar injection. Then, in November 2022, China scrapped the entire design and replaced it with a fully reusable rocket. The new Long March 9 ditched the 4 side boosters for a single core design that looked exactly like a painted SpaceX Starship. It's not an art competition, it's spaceflight. Physics dictates design choices, not aesthetics. There's only one correct answer to building the ideal reusable upper stage rocket, and SpaceX got there first. This is the ultimate Apple move at the national level. China watched SpaceX perfect the economics of reusability, bypassed the trial and error phase, and went straight to the most efficient design. They're interested in a high-capacity supply chain capable of hauling 50 tons of payload directly to the moon. By 2032, they're testing this Titan. It won't just carry people, it'll carry the heavy machinery needed to build a city. They're commoditizing the journey to the moon. When the trip becomes cheap and repeatable, the moon stops being a destination and starts being a resource. Right now, China is auditioning robots to solve the 2 biggest problems of colonization: water and shelter. And they're doing it with a track record that's unprecedented. Literally every Chang'e mission has succeeded. 2 critical missions are launching soon. Chang'e 7 in 2026 targets the lunar South Pole to find water ice trapped in permanently shadowed craters, places that haven't seen sunlight in 2 billion years. The lander will deploy a rover and hopper vehicles. The rover uses a drill to sample material from the bottoms of ancient craters, feeding samples into a heating furnace on board to detect water molecules. Water is life, It's oxygen to breathe. It's hydrogen for rocket fuel. Finding it means China doesn't need to ship every drop from Earth. Chang'e 8 follows in 2028 with a 3D printer designed to melt lunar regolith at 1100 degrees into interlocking bricks. A 100-kilogram operational robot will transport these bricks to a working area and assemble them into basic structures. This is the first human construction project on the Moon. Chang'e 8 will also carry a seismometer to map the lunar interior and measure micrometeorite impacts, critical data for planning long-duration crewed missions. This is their construction permit. If a robot can build a hut out of moon dust, China doesn't need to ship expensive materials from Earth. Once the bricks are laid and the water is mapped, the mission shifts from exploration to occupation. The real endgame begins after 2029 with the International Lunar Research Station, ILRS. Apollo's legacy is landing, planting a flag, and leaving for 50 years. China's designing their program to avoid this entirely. Between 2031 and 2035, 5 dedicated missions will build a fully autonomous installation at the South Pole. ILRS-1 establishes the command center with basic energy and telecommunications. ILRS-2 brings research and exploration equipment. ILRS-3 focuses on resource utilization technology. ILRS-4 deploys robotic exploration platforms. ILRS-5 establishes astronomy and Earth observation systems. It's a distributed network that stays operational long after astronauts leave. By the mid-2030s, this station runs primarily on robots. This is colonization. China started this project with Russia, but Russian involvement faded. Now they're inviting partner nations, Pakistan, the UAE, Turkey, Mongolia, Thailand, Peru, Iran, Bangladesh. They're building a global coalition that bypasses the Western-led Artemis Accords. China aims for 50 nation partners and 500 international collaborators. They're establishing a new status quo where Beijing sets the rules. Supporting all of this is the Kuekiao satellite constellation, the world's first lunar navigation and communications service. By 2045, China plans an orbital component to ILRS as well, a space station hosting continuous experiments above the lunar surface. But a permanent base needs permanent power. Solar panels don't cut it during the 14-day lunar night. China has a 2-phase energy strategy, and it ends with nuclear dominance. Phase 1 is a land grab for the peaks of eternal light, specific spots on crater rims that receive near constant sunlight. By landing on these peaks, China secures the best real estate on the Moon. The lunar South Pole is where the sun never gets very high in the sky. There are craters with rims where sunlight never reaches the bottom, permanent shadow. These are cold traps where temperatures stay hundreds of degrees below zero, preserving water ice from comet impacts over billions of years. The Apollo missions stuck to the flat seas like the Sea of Tranquility, but the South Pole is where the real value lies. Solar panels can work for 2 weeks of continuous sunlight, but then the sun sets for 2 weeks of darkness. A lunar day lasts a month. Batteries don't like being at 200 degrees below zero. The chemistry fails. You need power to melt soil into bricks. Phase 2 is nuclear. China has formalized plans to build an automated nuclear power station on the Moon by 2035. This is a fission reactor using uranium designed to produce 100 kilowatts of continuous power, enough to sustain a small settlement. The reactor is self-contained, based on prototypes already used at military bases. It can be buried underground for protection from asteroid impacts. It runs 24/7, independent of the sun, effectively turning the Moon into an industrial domain. This reactor will power the entire ILRS operation, supporting heavy manufacturing, life support systems, and scientific research.
It's the heart that keeps the base alive. The moon becomes an industrial domain. The base transitions from research station to permanent extraterrestrial settlement. It's a geopolitical power projection that changes the conversation from "can we go back" to "who controls what's there?" China's roadmap for the next decade extends far beyond that 2029 landing. The initial human mission gets the headlines. The strategic shift, that happens in the years immediately after. China is transitioning from exploration to industrialization, anchored by the International Lunar Research Station. By 2035, the objective is a base powered by nuclear energy, surviving the lunar night, supporting heavy industry. This isn't Apollo. They're not designing a system for visitation. They're designing it for permanent occupation. The next decade transforms the moon from a frontier into a domain of strategic competition, and China is building the infrastructure to stay.
If you enjoyed this video and want to see more visions of the world of the future, please like the video and subscribe. It helps the algorithm push our videos to more people.